Hi everyone, this is example 1 from chapter 18. Chapter 18 talks about paired t-tests. Paired t-tests, we run those when we have two samples, but there's a connection between the two samples. So let's look at this problem. It says, recent research suggests that a pregnancy within less than 2 years of a live birth might be associated with an increased risk of autism in second-born children. Below is a data set containing the ages of 15 siblings. Does the sample indicate that couples are waiting more than 2 years before getting pregnant with a second child? So notice that we have two different samples here. Sample 1 consists of the ages of the firstborn children, and sample 2 are the ages of the secondborn children. So these children are connected because they're siblings, they're from the same family, and that's why this is a paired t-test. So what we want to do is we want to put the ages of the firstborn children into L1 and the ages of the secondborn children into L2. And then in L3, we're going to subtract L1 minus L2 so that we can find the difference between the two samples. So if you move your cursor up to where it says L3, you can then type L1 minus L2 and it will automatically populate. So you shouldn't do this by hand. It should populate when you hit enter after this, and you should get these pairwise differences for L3. So we are doing a paired t-test. And I want to look at the hypotheses. And when we write hypotheses for paired t-tests, we are always using mu sub d. Mu sub d represents the mean difference. So in chapter 17, what we did was we found the average, the difference between the averages. Now we're finding in chapter 18 the average of the differences. So there's just a slight difference there. So this is asking if couples are waiting more than 2 years before they get pregnant. And a pregnancy usually lasts about 0.77 years. So if parents are waiting more than 2 years, then the difference between the ages of the siblings should be more than 2.77. So that's the alternative hypothesis. And with our textbook, we always use equals for the null hypothesis. So now we're gonna run a t-test on L3. So we're gonna go to stat, tests, and you're gonna choose the t-test, number 2. But now you're gonna change, usually it says L1 there, we're gonna use data. Our mu sub 0 is 2.77, and now for list, we're gonna have L3. Frequency is always 1. I forgot the R there. And we are looking to see if mu sub d is greater than that 2.77. So this is going to say mu is greater than mu sub naught. And when we put this into our calculator, we get a test statistic of negative 0.4. That is not very remarkable. And we get a p-value that equals 0.65. That is a huge p-value. So that p-value is way above any significance level we would ever choose for this problem, which means that we are failing to reject the null hypothesis. So I don't have a lot of room to write that conclusion, and on the next page I'm going to talk about a conclusion, but so we're failing to reject that parents are not waiting more than 2.77 years. So coming over here, let's find out what this sample indicates for how long parents are waiting before they get pregnant with their second child. So we are going to do a confidence interval for L3. So we're going to go to stat and tests, and we're choosing T interval. And again, we're going to do this, run this T interval on L3. So T interval is number 8. So we have data. The list will say L3. The frequency, again, is always 1. And let's just do a C level of 0.95. So our 95% confidence interval comes out to be 2.1075 to 3.2232. So let's write a conclusion and kind of try to tie this over to our test. So according to our confidence interval, we are 95% confident that the true mean, that says mean, mean of the differences in the ages of siblings is between 2.1 and 3.2 years. So this sample is indicating that the difference between the difference in the ages is of siblings is between 2.1 and 3.2 years, which means that this sample does not support the idea that parents are waiting longer than 2 years. It could be that they are. We do have an upper limit in our confidence interval of 3.22, but remember, we don't know where the true mean is, so the true mean could be 2.1. We're not really sure. We're just 95% confident that's between these two values, which means that our sample does not support the conclusion that parents are waiting longer than 2 years to get pregnant.